Good morning and welcome to the NOVONIX Investor Webinar. Today from the company we have Managing Director Philip St Baker and CEO Chris Burns. I'll pass over to Philip shortly, however just a reminder that you're all on listen-only mode and questions submitted prior to the webinar will be addressed at the conclusion of the formal presentation. Phil, I'll now pass it over to you. Thanks very much.
Thanks very much. And look, I understand we've got quite a few people on the line, about 750 or more. So, which is excellent, and so welcome to all of you. Today, this is our first webinar that NOVONIX has done, and I'm pleased to say that we've got quite a special webinar today for you, and what it's about is really giving you a glimpse of the future for NOVONIX, and it's about what is next with the company, with a really strong focus on our technology roadmap. So it will give you, what I'll do is I'll hand over to Chris Burns, who leads our business in North America and essentially leads the technology roadmap and the technology development of the company. So I'll get Chris to take you through that presentation, then we'll hand back for Q&A. So that'll run for about 20 minutes. Just before I do that, I want to give a little bit of an intro to Chris. Chris is a founder of NOVONIX. Chris Burns and Dave Stevens founded NOVONIX. It was spun out of Jeff Dahn's lab from Dalhousie University. I believe when Jeff's group was exclusive to 3M Corporation. And prior to that group, which is now dedicated to Tesla exclusively. But Chris and Dave spun it out of Jeff's group, formed the company and was very successful in pushing that testing technology out to the world, to the R&D battery world. I guess at the same time, Chris wore another hat. He was a senior engineer, battery engineer for Tesla itself while he was founding NOVONIX as well. So that's an important bit of background I wanted to give you prior to handing over to Chris to take you through what's next with NOVONIX. So with that, over to you, Chris.
Great, thanks, Phil. So as Phil said, we decided to take a bit of a different approach in today's webinar than our typical announcements. I think in the past few weeks, we've updated investor presentations around the capital raise and really discussed a lot of the business strategy of the company. So we thought we'd take today to get a little more technical about the projects we're working on, some of the recent announcements about single crystal cathode, the importance of that, and really the holistic view of NOVONIX as a battery materials company. So we're all here because of the growth in the lithium-ion sector, and really what's driving that growth is electric vehicles and energy storage systems. So all the growth in the lithium-ion market is going to come from applications that require long cycle life and high performance. So cell phones, laptops, consumer electronic devices, these are things that can get by with cheap materials and short cycle lives that just last a few years. But with the emergence of electric vehicles, energy storage, we need higher performance materials while still driving the cost of lithium-ion batteries down. So you can find this type of data in a million ways, but it's clear the electric vehicle revolution is here, and that's going to turn into a huge amount of increase in battery production, and subsequently the requirement for all those raw materials or those input materials to batteries. So when you look at the primary components of the battery, the anode material, typically graphite, and the cathode material, typically a nickel, manganese, cobalt material, the total addressable market today is about $10 billion US, and that's going to grow by about 7 times over the course of this decade. So this materials market to service this industry is growing to $50 to $100 billion over this decade. So as Phil said, NOVONIX is set up as a set of companies working on new materials. And one of those companies is NOVONIX Battery Testing Solutions or Technology Solutions, working on precision equipment, development technology, and new material incubation. We have our pure graphite anode material business in Chattanooga, Tennessee. And we're excited to start a new arm of the business around the cathode technology that we've recently announced. we're very interested in the possibilities of moving this technology to market, and we believe there's strong value in putting a dedicated team in place working on these. So all of these companies operate under the NOVONIX Limited listed company, ASX, NVX is the ticker, and we're investigating a North American listing as well on the OTC market. So I'm going to talk about some of the technologies that are being developed at our NOVONIX Center in Nova Scotia. One of our core technologies, our first commercial application technology of pure graphite materials coming out of Tennessee, and then as well the new cathode work, which spun out of our work with Professor Obervac at Dalhousie University and our work at NOVONIX in Halifax. So really, as I said in the kind of preamble, the interest in new materials is to drive long cycle life applications. And the electric vehicle market is very much here and now. And so you see this type of media coverage around the idea of a 1,000,000-mile battery, right? So can we make lithium-ion batteries that will power a vehicle for 1,000,000 years, or 1,000,000 miles, sorry. 1,000,000 years would be great too. But along with this is the need to support energy storage systems, which require that type of lifetime as well. So when you look at the critical elements of a 1,000,000-mile battery, you have to have a high-performance, long-life anode material, a long-life cathode material, and electrolytes to enable those materials to cycle continually under these conditions. And we really work on all of these elements with internal technologies. Our pure graphite anode material has been developed and is currently scaling on the back of a contract with an initial contract with Samsung SDI. Our new cathode developments are really going to enable us to pursue a dedicated arm of the business around cathode technologies. It's under development, moving to pilot scale with some core IP filed around the technology. And a lot of our team in Halifax's background comes in high performance electrolyte and demonstrated performance around electrolytes that can enable long life applications, and we're filing patents around some of that technology as well. So we've talked about these types of technologies over the past few years, with the company really transitioning to become this diversified battery materials and technology company. And we've always presented our technology roadmap as starting with our high precision charger, or HPC technology, that was what NOVONIX in Canada was founded by and spun out of Jeff Dawn's lab, as Phil said. And this is a battery testing technology that allows us to accelerate our research and development, get answers to the performance of materials in weeks instead of months or years. And this is a technology that we developed and we sell, and we work with tier 1 battery manufacturers and OEMs around the world. We have other patented analysis technologies like our differential thermal analysis, or DTA technology, which is an investigative tool to learn about electrolyte degradation over time. And then we start looking at the acceleration of programs around the core battery components. And everything we're looking for is a higher energy per cost long life material. So our high energy per cost synthetic graphite material, this is based with our pure graphite business. We have sales of that material starting at the end of this year with Samsung SDI. We have technologies around silicon graphite composite materials, patent applications that we've filed and been working on developing over the past year or two. Lower cost is really the focus of long life cathode materials with our DPMG, or dry particle microgranulation technology, which we filed 2 patents around. And with our group at the university, we're working on other long life applications and future battery technologies around solid state and the things you hear about as the next generation class of technology. But these materials, we believe, and it's clear in the industry and market reports, that these are probably going to start gaining adoption around 2030. So the runway for the traditional battery chemistries, high nickel versus graphite-based chemistries, have a long runway to dominate the growth coming this decade to service electric vehicles. And in the background of all of this is enabling electrolyte systems to assist in our anode materials, work better with the silicon, allow us to go to high voltage with the cathode materials. So, and again, as I said, we've had a strong background in this. It's really where my work in batteries started over 10 years ago. So today I'm going to talk about those in the boxes are our anode materials, cathode materials, and electrolyte systems, and really how these three coupled together support million-mile battery technologies. So I'm going to start with the anode material. So these are some slides we've presented before. They're in some of our decks, but I think they're pretty important to cover. You know, when you look at anode materials, graphite materials for lithium-ion batteries, there's a number of key components. They need to have a high capacity so they can store a lot of energy, a high first cycle efficiency, a long cycle life to support electric vehicles and energy storage systems, a low cost because everything is about driving cost out of the batteries, and they need to have a high safety and purity and quality, and people want them to be produced in an emissions and chemical free manner. And these are really what we set out within Pure Graphite to develop a competitive technology and competitive material with those existing on the market today, but something we could scale outside of China. Right now, the dominant market share of graphite material is coming from China, and there's two forms of graphite: natural graphite that's mined out of the ground, and synthetic graphite that's produced through other carbon precursors. So we've tried to summarize the state of class of these types of materials, with natural graphite having high capacity but low cycle life. There's very good synthetic graphites out of Japan, but they're very expensive. There's a range of mid-tier synthetic graphites out of China that are cheap but lower performance. And I shouldn't say cheap, they're lower cost than the Japanese synthetics. And then we have our pure graphite material, where we're able to achieve the highest cycle lives, very pure, safe material, high first cycle efficiencies and capacities. And that's what everybody is looking for. And we're doing all of that based out of the United States. So as I said, the rest of the presentation, we're going to get into some of the data and really look at what it means to have materials that are outperforming some of those in the industry. So we use what's called the columbic efficiency, and it's a round trip measurement of how much charge is stored and how much charge is delivered within the battery every cycle. And if that value was exactly 1, then the battery would deliver exactly the charge that was stored, and the battery should last forever. And this is the technology and the equipment testing technology that we developed starting back in 2008, 2009, where if we could find materials that had columbic efficiencies closer to 1, then it meant they would have a longer cycle life. And we could make those measurements in only a couple weeks. So you see on the top plot, columbic efficiency going up to exactly 1, and only 20 cycles. And we can easily differentiate cells with the NOVONIX, the pure graphite anode material. These are Tesla cylindrical cells from a Model S, used just as a reference. Chinese synthetic graphite and natural graphite. And you see after 20 cycles where things are ranking in terms of performance. And when you look at what that translates to into long-term performance over hundreds and hundreds of cycles, you can see that the NOVONIX material is coming out on top, and then the Chinese synthetic, the Tesla cell has a very linear fade later in its life, and the natural graphite just can't compete for these long life applications. And this is the way we approach all of our battery development programs. We generate comprehensive data around the materials and their performance before we start bringing those materials to a customer. Because in this industry, and I've seen it over the years, you don't get a lot of chances. You can't come with a material that's subpar and then keep trying. So people want to see that you can demonstrate value and you know what you're doing. And when we have the backing of our prototype center here in Halifax, where we do all of our battery design, build, and testing, to show that we can compete or beat the best things in the industry, when our materials get sampled and tested by potential customers, we know the results they're going to get because we do all of those measurements and all of that extensive testing internally first as part of our product development programs. So this is all reflective of the material that has moved to a contract with Samsung SDI. And so I will touch briefly on the growth plans for pure graphite, because this is, as we set out on our mission to build better battery materials, our first commercial success. So we started Pure Graphite about 3 years ago. We brought this product to market. We worked with Samsung starting at the beginning of 2019 and moved to a supply contract at the end of the year that we're moving up to start deliveries about 12 months after we sign that deal later this year. So our initial ramp over the next 2 years is to build out 2,000 tons of capacity. You can go to the investor deck. This is pretty well documented around the capital raise and what we want to do to support the Samsung contract and potentially some smaller, excuse me, smaller contracts as well. And then as we move over the subsequent years, we want to ramp to 25,000 tons per year. We'll be exploring facilities in Europe due to the demand in Europe. And we expect to bring Sanyo on as a customer based on our relationship and our progress with them and expand this customer base. And then moving to the back half of the decade is really our phase 3 plans of going to 100,000 tons per year. And this will be on the back of taking a major piece of the supply chain for companies like Samsung or Sanyo as they continue to grow their requirements around the world. So as I said, we have agreements in place with 2 of the largest battery manufacturers in the world, Samsung SDI and Sanyo, which is a subsidiary of Panasonic. The supply agreement with Samsung is for 500 tons of our synthetic graphite material to start delivering later this year, around October. And then we'll be working toward a longer-term supply contract. We had committed to build 500 tons per year of capacity ahead of a contract to prove production capability. And after sampling the material and testing it, Samsung said, okay, we will buy that run rate of capacity. And when you can show that you can deliver consistent, high quality product from that line, then we will revisit a multi-year scaling contract. Because like everyone else, they are motivated to remove their reliance on China for their battery materials. And Pure Graphite is the only option in North America to do this. And another important part of the Samsung agreements is an R&D collaboration agreement, because we explained to Samsung our approach to battery materials design and development, and they said, this is what we need, right? We need companies that are going to push the envelope and continue to improve today's technologies and drive the cost out and be able to provide alternate supply chains outside of China. So I'm underlining that because that's really what the rest of this presentation is going to focus on with some of our other technologies. And then in addition to the Samsung contract, we have a non-binding MOU with Sanyo, really around defining the testing program. We've already sampled materials to them, and then there will be subsequent testing programs that are happening in an effort to move toward qualifying the material and signing a supply contract to support their expansions as well. So, this is a major accomplishment that nobody else has been able to achieve, actually, to sign a supply contract and other deals with the major 5, companies from the major 5, Panasonic, CATL, Samsung, LG, and SK, battery manufacturers that really dominate the market share of battery manufacturing today. So that's the status of our Pure Graphite operation. And like I said, with the rest of this seminar, I'm going to talk more about the R&D aspects of the business and this question of what's next on our roadmap. So we recently have announced progress around our cathode program with a technology called DPMG, or dry particle microgranulation. So if you look at the current process for making cathode materials such as NMC or NCA materials, it's typically done through a continuous third tank reactor using expensive precursor materials and a complex wet chemistry process that produces significant waste before making a precursor material that is sintered or heated with lithium to make the final NMC product. So there's a number of, there's a lot of groups working on how to refine this process, how to do it better, how to have exact control over the process. But working with Dr. Mark Oberbach at Dalhousie, he had a fundamentally different approach to the technology, which was, can we make materials through not the same process? We don't want to optimize this expensive process. We want to find a cheaper way to make high quality precursor materials that we can turn into NMC. And so what he and the team discovered was really this dry particle microgranulation methodology, where through a completely dry milling process with lower cost raw materials such as oxides or carbonates instead of sulfates, we can make the same quality precursor materials, heat them with lithium, and make final product of NMC or NCA type materials. We can also use this technology in anode to spherinize graphite with 100% yield. And we went through that in some of the other presentations as well, but I want to focus this technology on the cathode for the purpose of today's discussion. So when looking at this, we worked on this within the lab, and we're starting to scale it within our NOVONIX operation in Canada. And we can make materials that are polycrystalline in nature, which is the kind of traditional cathode structure where the particles are made up of small, let's say submicron or micron sized primary particles, and they're agglomerated into larger spherical, roughly shapes of say 10 microns on the order of. And we filed patents around the process and the materials around polycrystalline, and we can make advanced structures where we can change the concentration of nickel, manganese, and cobalt from the core, the middle of the particle where we want it to be high nickel and very energy dense, to the shell where we want it to be lower nickel and a safer, less reactive material. So these are all things that the industry is doing through the expensive conventional process that we're showing we can do through a dry, low-cost process. And when we worked on that, we said, you know, we need to find a way to also be able to make single crystal cathode materials. So single crystal cathode materials, instead of a polycrystalline agglomerate of these micron or submicron sized primary particles, single crystal are essentially exactly as they sound. They are made up of only a couple grains. And you can see in the image here, each of these particles with facets looking kind of like a gem is actually one grain of the structure. So I'll get to why this is important in a minute, and you'll see that demonstrated through the rest of the process. But you know, because of our activities and our involvement in battery design, testing with leading companies and material suppliers around the world, we understand where the market is moving, and these single crystal materials are going to be the future of the high performance class of lithium-ion cells for electric vehicles and energy storage systems. So that's why once we discovered we could use this process to make polycrystalline materials, we immediately started working on single crystal technologies as well, and have subsequently filed another patent application around, again, the process, the precursor materials, and the final materials made through our dry processing, through our DPMG technology. So let's talk about why single crystal. So it's emerging as a key part of, you know, this million-mile class of batteries, and companies like GM and Tesla have been vocal about pursuing this. Professor Jeff Dawn has also filed patents around different ways to use the traditional methodology of continuous stirred tank reactors to make these single crystal materials. But again, we have developed a technology with Professor Obervac that is owned outright by NOVONIX with this dry synthesis condition. And when the importance is that when you look at these long life applications, the materials are more robust in the single crystal form. So what's shown on the right here is an image from a paper that shows a cross section of a single crystal particle and a polycrystalline particle on the bottom. And you get cracking within the grain structure of the polycrystalline after extended cycling, and is illustrated in the schematic. This can lead to capacity loss. But the single crystal material is very robust and resilient to this cracking over time, and that helps it achieve much longer cycle lives. And so when you look at some commercial materials for single crystal versus polycrystalline materials, again, we do all of this work internally with our pilot line in Halifax, where we build pouch and cylindrical cells and do extensive testing on our high precision systems, long-term cycling, power, rate capability, everything that you need to do to qualify high performance materials. You can see that when we build apple-to-apple cells and compare a single crystal NMC 622, so 60% nickel, to an analogous polycrystalline 622, These are cycling at 40 degrees C to 4.3 volts. And you can see they start out for the first 50 or so cycles right on top of each other. But this is where the single crystal shows that it's much more robust to cycling. The polycrystalline material continues to fade over time, gets to about 80% where we consider end of life after 400 cycles in these cell designs. And the single crystal is still at 92% and flattening out for what will be a much longer cycle life. So we understand the value of single crystal. We see it every day in our design and development work, and in supporting our anode program, we use single crystal commercial materials to really illustrate that we were competitive with the best state-of-the-art materials. And you need these single crystal materials to support things like the million-mile class of batteries. So now let's look at the third leg. We've talked about anode materials. We've talked about the cathode materials and the importance of single crystal. And running in the background of all of this is the importance of electrolyte. So the electrolyte sits between the anode and the cathode. It serves as the medium for lithium ions to be transported back and forth. And it dictates how, in many ways, it dictates the longevity of the batteries, because the electrolyte reacts with the cathode and the anode materials in the charged state. And the rate of this reaction is what eventually leads to cell failure. And again, when we started on our high precision coulometry program, a huge body of work, and this was 10 plus years ago and continued to be, was around supporting higher performance electrolyte systems, screening them with our rapid R&D tools of HPC, and then showing that they could support very long cycle lives as we anticipated from only a few weeks of testing. So we have a very strong team here with a background in electrolyte development. And what we've shown is, again, we can build commercial materials, single crystal NMC622 versus commercial synthetic graphite. And with a baseline standard commercial electrolyte package, in these cell designs at 40 degrees C to 4.3 volts, you're at about 88% capacity retention in 1,400 cycles. So there's a lot of cycles. And then when you look at electrolyte packages that we work on and are developing, you can see the performance improvements. And these may not seem stunning when you first look at it, but you have to realize the battery performance game is a competition for every inch of benefit you can gain. So this improvement in 2% can translate to much more than that when you look at the longevity of the cell. And if you can get a 2% win for no real extra cost in an electrolyte formulation change, that's a win that every manufacturer is going to move towards. So electrolyte is this key component, a huge background of our team to enabling advanced materials that are going to last, advanced cell designs that are going to last for electric vehicles and energy storage systems. So when you really look at what this means, when we think about our battery cell technologies and our roadmap, we understand that the industry movement toward NMC and even higher nickel materials, 811 or 9.5 versus synthetic graphite. That's kind of where the world is now, and moving into single crystal materials. And then we start to say we can add our advanced electrolytes and improve those performance, and we can displace the standard synthetic graphite with our pure graphite material and further improve the performance. And moving forward with our new working cathode, we want to displace the single crystal cathodes of today with new lower cost options that are made through our dry processing technology. And when you look at what this means in real data, you see the NMC graphite with commercial materials in these cell designs and test conditions, about 400 cycles as we saw before. You switch out to the single crystal material, you're at about 92% in 400 cycles. You include an advanced electrolyte package. Again, you can bump that up by 1% or 2%, and you can see that extends out 100 cycles to the same capacity retention. And furthermore, when you switch out the graphite for our pure graphite material, and this is really why people are so interested in our pure graphite material, you get this huge capacity bump in retention relative to traditional materials. So this is the way we approach all of our materials development programs, all the way from the work we're doing at the university at early stage to our developed commercial programs at Pure Graphite and our continued product development there is we know where the benchmarks are, where the state of the art is, and we know how we have to beat it. And when you look at what this really means in terms of long-term performance in applications, and you start talking about vehicles and this million-mile battery technology, in these energy density classes, 1,000,000 miles is achieved around 3,000 cycles. And so on the previous slide, you see we're out of 700 plus cycles, and we have other cells that are out further with different technologies in them. But you can generally see the trend that these are fading on, where the commercial polycrystalline and synthetic graphite material, it cannot meet these type of demands at 40 degrees C to 4.3 volts. You go to the single crystal materials with graphite and you can get, between, let's say, 500,000 miles or more. You improve the electrolyte performance and you start to understand how these curves swoop out in time, and you're now targeting out at 1,000,000 miles. And when you take the bump in performance that you get in moving to the pure graphite material, same energy density, much longer cyclability, you can see we're going to be able to easily surpass 1,000,000 equivalent driving miles with this cell technology at 40 degrees C, right? So when we look at what's next, everything is around being able to support materials at lower costs and diversified geographical supply chain outside of China that can meet this class of materials. And this is really showing that, all of our internal NOVONIX technologies can support these 1,000,000 mile plus type of batteries. And so when we look at NOVONIX, NOVONIX is delivering battery materials for the EV industry and the renewable future that it needs today. It's redefining manufacturing processes. That's what we did with our pure graphite programs to lower the cost. That's what we're doing with our cathode development programs. We have core competencies across all the areas of materials development, cell design, and technology. We have a great board behind us and strong connections to leading companies within the battery manufacturing, auto, or OEM space. We've demonstrated our technological advantages in anode, cathode, and electrolyte, and we have more coming beyond this presentation as we keep moving all of these programs further. And really, this first commercial success has been achieved in our pure graphite business with the contract with SDI that we're currently scaling for. And it has always been our mission that was the first commercial success, and our incubation program within NOVONIX in Halifax and working with the university is to bring further materials to market. So we're the only company to break into this market and actually have a supply contract from North America or Europe. And this cathode technology is entering its pilot phase, moving into commercialization now, and we expect that that's an emerging class of materials and a technology that's going to be very important in the future. The cathode market's about 3 times bigger than the anode market, simply because of the material you need and the cost. So again, all of the cathode and anode space are $10 billion market today, going up by 5 to 10 times over the course of this decade. And we plan to become a tier 1 supplier of these materials across a broad spectrum. And so that's really what I wanted to talk about today, was take a bit of a turn from the traditional investor deck, discussing the business model, discussing the business plan and the scale. I think, we've shown our plans there around our pure graphite business and shown how our incubation program works within NOVONIX and at the university. And so we wanted to take a bit of a turn and really show some of the technical data and the performance data to show that all of the materials that we are working to develop are competing with the state of the art of the industry. And they all are supporting these 1,000,000 mile class of batteries to enable electric vehicles and grid energy storage in the future, which is where the real growth for battery materials comes. So I think I'll end it there, and we can look at some of the questions that were submitted, unless Phil has anything he'd like to add.
I think we've got the questions.
Great.
Okay,
Thanks so much. Thanks so much to Chris. That was extremely comprehensive and much appreciated. We've had a number of questions that have been submitted. Just mindful of time, we'll try and get through as many as possible, but I'll kick off. Who should we expect your future business partners to be?
Sure. So as we've demonstrated with pure graphite, our focus is on working with mainstream battery manufacturers who are using these types of materials and purchasing in volume. or potentially for new cathode technology, we may be looking at partnerships with people in the manufacturing space already. But we will always be looking at the tier 1 class of customers and partners to move forward our business plans, and they will be primarily in the auto and energy storage sector, because that's the high performance class of materials we make.
And would there be a partnership directly with Tesla, or is that through the agreements between Samsung, Panasonic and Tesla?
Yeah, so we're focused on people who have a supply chain or who are going to be buyers or influencers of that supply chain. So of course, these agreements with Samsung and Panasonic exist because they are existing battery manufacturers. They have established supply chains that they are looking to grow. And of course, there's a lot of coverage around Tesla's expansion toward being vertically integrated and building their own cells. And so they would certainly fall in this list of companies that would be interested in working with around our materials.
Right. Recently, the CEO of Nikola Corporation mentioned in an interview Samsung/Panasonic are also supplying them for their hydrogen electric vehicles. Would NOVONIX also be partnering with someone like that for their passenger vehicles and trucks?
Sure, I think that's definitely a possibility. Right now, they're kind of a similar business model to what Tesla was, where they're going to work with existing cell manufacturers. And so working with, for example, Samsung, and we are already working with them. But of course, if Nikola starts to be a decision maker and a mover in their own supply chain, then there's certainly a company that we would be interested in working with.
What moat does NOVONIX have in developing and commercializing the DPMG method?
Yeah, the DPMG method, the important thing to understand is this is a completely new technology, and what we've really filed are what we'll call kind of ground floor patents around the use of this technology comprehensively in anode and cathode. So depending on the type of technology, we take a different IP strategy, and here we decided to take a patent filing strategy because we believe this is a very important technology for the future. And so these ground floor patents are really going to lay out the space in which DPMG is going to operate. And as other companies become interested in this technology, which we're already seeing, even as they potentially find subsequent discoveries, they'll still be living within the IP space of the use of the technology, which we will own. And of course, we are continuing to refine the technology, and we plan to file subsequent patents with the new discoveries we find.
Right. How much additional cost is associated with capturing that yield improvement, i.e. capital cost for specified output or incremental cost as relevant?
Yeah, the capital cost of implementing DPMG technology is, let's say, not going to be excessive. It's an established scale technology that exists for a number of industries, but we don't have great numbers now because, again, we're taking this through to pilot and demonstration scale now. But certainly we believe that through making up the yield losses in, for example, the graphite manufacturing process, it would easily pay for the capital expansion required for the additional step of using DPMG in the process.
Right. Are there other novel chemistries that are being pursued using DPMG that provide potential competitive advantages that were more difficult under previous methods?
Yeah, that's a great question. So there's the short answer is yes. So through the dry methodology, we can use a number of different raw material inputs, and many of which are not compatible with the existing continuous stirred tank reactor method. So what this allows is that we could make materials that were completely inaccessible through existing methods. So these could have different dopants or different core materials in the metal layers. And so this can enable potentially a whole new class of materials. And again, we are exploring that while we're also scaling the most promising materials within the programs that we've discovered. And so that's why we really believe that DPMG can be a huge role in the future, can make everything that you can make in today's technology, but cheaper through a dry method. And it also opens the door to making new materials and new structures that could not be made before.
Right. Is there a forward plan on setting up cathode side similar to pure graphite? And if so, what are the volume scale up implications?
So the answer is yes, and as I showed in the beginning of this presentation, our interest is in setting up an independent entity within our structure to be dedicated to this cathode development work because we believe it has huge potential. I will say that in terms of volume and scale up, we are going to pilot now to demonstrate so that we can start generating these comprehensive data sets to show our current companies that we work with and also new companies, how well these materials can perform. But, I want to say it will not be, a product in mass production in the next year. It's still a program that's going to be demonstrated and be working with, people like Samsung through our R&D collaboration to prove that these materials are going to play a role in the future.
Could you please provide details on the Sanyo relationship?
Sure. So I think I touched on this in the presentation, but we've been working with Sanyo since early in 2019 around our graphite material testing, sampling, and they have been evaluating in their cells. And it was late in 2019, I believe, that we announced the MOU in place where they want to see production capability installed and the quality of the materials coming from the production line to continue to vet us as a potential vendor and qualify those materials from the production line and then be looking at negotiating a supply contract. So that's really where we are as we get the production lines running in Chattanooga to be helping to support moving that and supporting their final testing programs before we hope to be looking at a supply contract.
Great. And what is the financial impact on delivering on the Samsung order? What is the order? Is this a one-off order or is it an ongoing partnership?
Sure. The Samsung order is currently a one-off order for 500 tons, and as I said, it's because that was our planned installed capacity without a contract, and so they basically said we will buy that capacity. But they are extremely motivated to move their supply chain outside of China, and they do not see any other options except for pure graphite. And we are a viable option, a qualified material in their programs. And so once they see that we are producing material at scale with high quality, that's when we expect to transition from this one-off deal to a multi-year scaling contract.
Great. I would like to know how competitive your graphite business is compared to other international sellers. What about the graphite prices and quality of NOVONIX/pure graphite would make you the deciding factor for clients? How do you see yourselves competing with cattle in the same market space?
Yeah, so I showed the table around the different classes of material, from natural graphite to very high performance Japanese material to the medium tier Chinese, and really where we sit is in that high end sector with lower cost than the Japanese equivalents. So, in terms of the story to compel customers, it's really part of what I showed you today, and then a lot more backing that I didn't go through today to show the performance data under a number of scenarios and test conditions and chemistries and everything that cell manufacturers want to see as they vet potential suppliers. Regarding CATL, of course, we wouldn't be looking at competing with CATL. They're a cell manufacturer that has a supply chain that buys synthetic graphite today. So more than anything else, we would be looking at supporting CATL's expansion, especially outside of China, as they build factories in Germany, for example, to service BMW. That they will have pressure to not bring their supply chain from China and find localized supply chains, which is again part of the reason why Europe is on our expansion roadmap in phase 2 of pure graphite. And we think that there's a huge opportunity there with the likes of CATL.
We'll wrap it up after this question, but is there yet a forward plan on setting up cathode side similar to pure graphite? And if so, what are the volume/scale up implications?
I think we already touched on that one. Yeah.
There's been too many questions. And then the last one. So I've heard NOVONIX is currently working on scaling the manufacturing process. When do you expect to complete this And when completed, how long will it take to scale up operations to maximum capacity?
Yeah, so, around our pure graphite business, we will be delivering material to Samsung later this year on the contract, and that'll be kind of this first phase of demonstrated mass production. And this recent capital raise has really enabled us to build out this 2,000 ton per year capacity over the next 12 to 24 months to get ahead of servicing what we expect to be future contracts with the likes of Samsung and Sanyo. And then, of course, looking at the cathode side, it's a little earlier, as I've discussed, really moving to pilot and demonstration phase now, where we can start to show compelling data to folks like Samsung and Sanyo and garner interest and partnership around our cathode technologies the same way we did around our anode technologies.
Great, thanks very much for that, Chris. I might just hand back to you and Phil for closing remarks before we finish the presentation.
All right, Chris, I'll just wrap up. And look, Chris, thank you for delivering that very comprehensive coverage of the company and where we're headed. Look, in terms of just closing remarks from me anyway, I just wanted to highlight that in terms of potential, the main companies that we're working with at the moment being Samsung and Sanyo, both of those companies already consume in the order of 20, 30, 40,000 tonnes of anode material per year. So our 500 tonne contract is really just the start. And both of those companies will grow into the hundreds of thousands of tonnes of demand for anode in 5 to 10 years. And same can be said about the other companies that are sitting right behind them, LG and SK Innovation. So, this is forecast to go from hundreds of thousands to millions of tonnes of requirement in the next 10 years. And our company, and when you look at the cathode side, which is even bigger than that, it's typically 2 to 3 times bigger than anode. We have potential here to grow an enormous company with a great potential to be a major provider within this market. So it's very exciting times. I think we've got an absolutely outstanding team. I think you've seen that today in Chris Burns and the team behind him in Halifax and in Chattanooga. And we have a really high-powered board that we've put in place because the opportunity is so big to make sure that we seize it and we execute it. So, I mean, from my perspective, I just wanted to add that to it before we close out. And was there anything further you want to say, Chris?
No, I've covered it. I think it's a really exciting time for me, really involved in the technology development. This has been, what I've been working on for the past decade plus. And it's exciting to see that, we really have an opportunity to play a major role in the expansion and growth of the lithium-ion battery sector. And we are developing materials that can compete with the best in class and outperform many of them. And it's a great time to be in this industry, huge growth ahead, and we have a great team working on all of these technology programs. So very excited to be a part of this for the next decade.
Great, thanks very much for your time, guys, and thanks everyone for joining. I know it's been a comprehensive and long presentation, but hopefully you found it well worthwhile. That concludes the presentation. Have a great day.
Excellent. Thank you.
Thank you.